Hello, my name is Kevin Jeremy,
Brandon Houston.
Yeah, secure.
and today we'll be explaining the PXY diagram.
Alright, so PXY diagram is used whenever you have two substances. It could be one, but in our situation it's two that are trying to be contained in equilibrium. PXY diagrams are used when your substances are in a liquid and a vapor phase in equilibrium. And in the liquid phase, your substance is usually at a higher pressure than your vapor. And in order for your substance to go from the liquid to the vapor phase, it would have to cross the bubble curve, which is the point at which your first bubbles or your gas begins to form. And from there, it would enter the VLE envelope.
Okay, so the VLE envelope is basically where the vapor and the liquid are at equilibrium. It's just one nice little mashup. There's nothing more of either one. So inside of this, on the diagram, you see the tie line. The tie line is where you get your vapor and your vapor and the liquid compositions, but you would get those compositions for the overall composition of the graph, depending on your substances that you're given. And to get out of the vapor or liquid envelope, depending on where you want to go, you have to increase or decrease your pressure. And then, in this case, we would be going to the dew curve.
Yes, and as you said, as you decrease your pressure, you start to enter the dew curve. And then once you decrease it more, you enter to the vapor phase, which has a low pressure. And it also is where you start to get your first drop of water.
And then, like we said, we also have a binary substance. So over here, you would have 0% of your substance one, which in our case is benzene. So over here, you would have 100% of toluene. So the saturated pressure of toluene would be whatever this number is. Then over on this side, you would have 100% of your benzene. So then your saturated pressure of benzene would be over here.
And that's pretty much all we have to you guys today for PXY diagrams. Thank you.
Thank you.
My name is Brandon Houston.
I'm Yasuki.
Kevin Jeremy.
All right, and today we're going to talk to you guys about TXY diagrams. It's very similar to the diagrams we just discussed to you guys, which is PXY. All right, so first we're going to start off with superheated vapor. It's technically just like the vapor phase, it's just that we're dealing with high temperatures. And instead of pressure, the TXY is TXY because it has temperature and not pressure. The pressure is the same. So but above the dew curve is called the superheated vapor phase. It's just because of all the high temperatures. And then you head into the VLE.
Yeah, but first to head into the VLE, you have to cross the dew curve, just as in the PXY diagram. That's where your first liquid is going to start forming. And in the VLE, it's the same thing as in the PXY. It's the phase in which your liquid and vapor are at equilibrium. They just coexist together. And in order for you to come into the liquid, you have to cross the bubble curve.
And when you cross the bubble curve, you get into the liquid phase, which is, well, in the liquid phase, you have very low temperatures. And as you see here, you have two boiling points. This boiling point is for the benzene, and this boiling point is for the toluene.
Yeah, and that's because over here, your component for toluene is 100%, so that would be the boiling point for toluene, as Kevin said.
And for this one, it would be
0% benzene, which is 100% toluene. So then it's the boiling point for that.
So, and the last thing that we didn't really discuss, the tie lines is the same thing as just on the last graph. You get the compositions for each and helps you get the overall composition for the graph. And that's all we got for you guys today. Thank you.
I was going to explain something real quick.
one more thing.
One more thing. I
Just going a little bit more in there what he said, so if somebody said they gave you 40% of benzene and you wanted to find out how much benzene is in the vapor, how much benzene in liquid, you go to 40%, go up, and then from there you'll be able to calculate the amount of vapor and the amount of liquid there is, or vapor and then liquid. And
That's all, folks.
Thank you.